Good day once again. This is still a continuation of your lesson on sets, and today's lesson will be set operations. So we have actually four set operations. We have union of sets, intersection of sets, complement of sets, and then the difference of sets. Now I will give you an overview here of the four operations. So you have symbols and keywords. For union of sets, you have the symbol is U, and the keywords, or you should remember these words because when you have a union, you combine or join together. And then for the intersection, you have inverted U. Intersection is actually the opposite of your union, and then so we combine, we get what is common. So you have there the keyword common, and then of course the complement, or you have here the symbol is just like an apostrophe. When you say complement, that's what make the set complete. So you have here outside of the set but still inside the universal set. And then you have here the difference. The symbol is just the subtraction symbol, and then the keywords for that you have there do not belong to the other set. Okay, let's have union of sets. So when you say union of sets, say A union B, that is you combine, you join two sets together. So that is how it looks like. The shaded portion is your A union B. And then for this example, you have here B is a subset of A. So you can have B subset of A, then A union B is just equal to A. Okay? And if I'm going to shade that, so you have here, I'm going to shade that so that you will have the same color with that of A, because when you get the union, that is all of this. Okay, and then let's have another one. You have here A union B, and if you notice, A and B are two disjoint sets, but when you say union, you still have to combine them. So the answer when you have A union B is equal to A or B, this together. And then you have here A union B is just like this because you have here, this is A is equal to B. Two sets are equal, then the union is just A or it's just B. Then let's have the properties here. So you have the first one, A union B is equal to B union A. And then you have that A union B, the group together, union C is equal to A union the group of B union C. And then you have A union A is A, of course, A union, okay, this is very important. And then of course this one, and then that's what I've said earlier. So if A is a subset of B, then A union B is just equal to B or opposite. Or you can say here B subset of A, then A union B is equal to A. And then of course the power set of the union is not equal to the individual power set of the sets. And let's have some examples here. Okay, so you have U is equal to the set of numbers 11, 12, 13, and so on to 20. A is equal to the set of numbers 11, 13, 15, 17. B is equal to the set of numbers 13, 14, 15, 16, 17, 18. And C is equal to the set of numbers 13, 14, 15, 16, 17, 15, 16, 17, 19, and 20. So A union B is equal to the set of, do not write the common elements, write it just once. So you'll have 11, 13, then you have 14, then you have 15, 16, 17, and then 18. Okay. And then B union A is just the same as A union B. Okay? So the elements here is just the same as B union A. How about B union C? So you have set of B union C. So what is common is 13, 14, 15, 17. So you will have 13, 14, 15, then you have 16, 17, and then you have 18, 19, and 20. Okay. Then what is A union B union C? So B union C is this one, so that A is 11, 13, 15, and 17. So what is common here, you have 13, 15, and 17. So you will just have 11, 13, 14, 15, 16, 17, 18, 19, and 20. Okay. Then what is A union universe? So A is always a subset of the universe U. Therefore, this is just equal to 11, 12, 13, and so on to 20, which is just equal to your U. And what about B union null? There's nothing, so we just have that as 13, 14, 15, 16, 17, 18, or simply we can have it as your set B. Then let's have intersection of sets. You have here the intersection, or what is common between the sets. So this part here is common. And then you have here A intersection B is equal to B when, so this is now the intersection, because when B is a subset of A, then A union B is B. Then let's have this. A and B are disjoint sets. So when you say disjoint, they have no common elements, okay? So that A union B is a null set. There is no common between A and B. And then let's have A union B is equal to A, or it can be equal to B if they are equal. So actually you can say that A union B is equal to A intersection B if and only if A is equal to B. Then let's have the properties here. So the properties of intersection of sets, you have here A intersection B is equal to B intersection A. And then if you group this together, they are actually, this one is this should be, that is A intersection B intersection C, okay? And then you have A intersection A is A intersection U is A, okay? This is very important. And then if A subset of B, then A intersection B is equal to A. And then of course this, and if you have union with the intersection of two sets, then it's the union of the intersection of each of the sets. And then you can have this, okay? Just remember that we will use this in our examples later on. And this one is very important. The power set of A intersection B is just equal to the power set of A union the power set of B. Let's have some examples here. Okay, we'll answer some of the examples that we have. So A intersection B. So your U is the set of 1, 2, 3, 4, and so on to 10. A is the set of numbers 2, 4, 5, 7, 8. B is the set of numbers 1, 3, 4, 5, 9. And C is the set of numbers 4, 5, 8. So A intersection B, is equal to, what is the common between, so you have 2, 4, 5, 7, 8. And then intersection 1, 3, 4, 5, and 9. So we want to find what is common between these two sets. So you have 4. You have 4 and you have 4. You have 5 and you have 5. What else you have there? Nothing more. So that is just equal to 4, 5. Okay. And then B intersection C. B intersection C, what you have there for B is 1, 3, 4, 5, 9. And here you have 4, 5, 9. So that is just equal to 4, 5. How about this? You have A intersection B, which is 4, 5. And then intersection, your C is 1, 3, 4, 5, 10, sorry. I'm looking at B here. So your C is, you have sets of 4, 5, and 10, so that the intersection is just 4 and 5. Okay. Then let's have A intersection B intersection C. So you have your A is 2, 4, 5, 7, and 8. And then intersection B intersection C, you have there number 2, that is 4 and 5. So your answer, what is common here, you have 4 and 5. Okay, so it's just equal to 4 and 5. Then of course A intersection U, your U is 1 to 10, and your A is 2, 4, 5, 7, 8. So this is just equal to 2, 4, 5, 7, 8, or simply A. And then of course A intersection of the null set, there is nothing in common between the two, so that is just a null set. Then let's proceed. The next one is our complement of sets. So you have here A, and the complement of A is everything outside of set A. So you have here the properties. A prime, or A complement, or the complement of A complement, is equal to A. And then A intersection A complement is null, so the intersection of this part here and this one is empty. And of course the complement of empty set is U, and U complement is empty. And then of course this De Morgan's law, you have A intersection B complement is equal to A complement union B complement, and then A union B complement is equal to A complement intersection B complement. So we will use these properties to answer some of the questions that we have here. So let's try. A complement, when you have U is 1 to 10, and then A is the set of all prime numbers, odd numbers, or prime numbers, yes. So from 1 to 10, so you will have A complement then is equal to what is not A. So you have 2, 4, 6, 8, 9, and 10. Okay, so you have here 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. That's correct. And then the complement of A complement is just 1, 3, 5, 7, which is just simply A. And then the intersection of this two numbers, the complement of A intersection A complement. Your A is 1, 3, 5, 7. Okay. The complement of that is 2, 4, 6, 8, 9, 10. So the intersection of these two is null set. And then A complement intersection B complement. Your A complement is, so we will write that. A complement is 2, 4, 6, 8, 9, and 10. Intersection B complement is 1, 4, and then you have 6, 7, 9, and 10. Okay, what is not B? So you have this, and then the intersection is equal to what is common here. You have 4, 6, and 9, and 10. So you will have, the answer is 4, 6, 9, and 10. And then let's have this. The union of A and B is union of A and B. You have 2, or write 1, 2, 3, 5, 7, and 8. Then you get the complement of this set. So you get the complement of the union of A and B, which is equal to 4, 6, 9, and 10. Okay. So this is your answer. We are getting actually the complement of this set here. And then, of course, U complement. What is the complement of U? And that is just a null set. Then let's have the difference of sets. Okay, so you have here A minus B. What is not B? This means that what is not B. So what is not B here is this part of A, the colored one. And then, so you have A minus B. If this is the case, so here you have A, or B, sorry, is a subset of A. Then A minus B is this part here, the colored one. And then let's have another one here. If A and B are disjoint sets, then A minus B is A. So remember that the shaded portion is the answer to A minus B here. And then you have A minus B is null. Okay, nothing there. They have, it's an empty set because A and B are equal. So when you are asked what is not B, it's nothing because what is B is also A. And then of course this one is the opposite, that is just B minus A. And if you, we will go to our properties later on, that A and B is not equal, A minus B is not equal to B minus A. So that is what I'm showing in here. So this is B minus A. So this is the answer. And then you have here B minus A is B. And then you have here B minus A. B minus A is null. If B is a subset of A, then B minus A is equal to a null set or an empty set. And then of course this one here, just the same with the previous example that we have. Okay, then let's have some of the properties. Okay, let's have that. You have example here. Let U be 1, 2, 3, and so on to 10. A is 2, 4, 5, 6, 7, 8, and then B is 2, 3, 4, 8, 10. So A minus B is equal to, what is not B is 5 and 6. So you'll have 5, 6, and 7, sorry. So what is not A here? B minus A is what is not A. So you have here 3, 4, 8, 10, and what is not part of A is 10. So you will have 10. And then you have A intersection B. So what is the intersection of A and B? You have 3, 4, and 8. Then what is U minus A? What is not A but part of your U is equal to 1, 2, and then what else? You have 5, 6, 7, 8, and then so you have 9 here and 10. So you have 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, that's correct. And of course, A minus U, this is A. What is not in A? So you will have what is not U, so that is equal to a null set. Okay, so because in here A is inside U, so what is not U is a null set. Then that's all for today. I want you to go to the homework page of our classroom, online classroom, because you have there your homework. This is your teacher Christina. Thank you very much for watching this video. Hope you understand, and I'll see you next week.